Hello everyone. In this session we are going to discuss worksheet questions based on waves chapter. Let us see. Question: which of the following wave has the largest wave speed? Wave speed, let me change the color. Wave speed V, wave velocity is equal to omega by k. That means coefficient of x, t this is, and quotient of x. Quotient of x is k, quotient of t is omega. That you need to check. Suppose first option is there. In the first option 2 by 2 is 1, and the second option time quotient is 3 and this is 2. So 3 by 2, 1.5. And the third one is 2 by 3. Fourth one is 2 by 5. So B option obviously the bigger one, right? Yes. Next. These are all less than ones, you know, no? Already here we have greater than 1. Largest is asking. So you are expert in mathematics. Two strings A and B produce beats of frequency delta F1 greater than 0 and tension in string A is lightly increased and the beat frequency is found to be delta F2, of course. And the original frequency of A is F0 and delta F2 is less than delta F1. Then the frequency of B is, it's possible. Why? Because tension of the string A is lightly increased. Tension of A increases means automatically A frequency increases. Frequency of A, which is he told F0, F0. If you increase the tension, then F0 will increase. See, on a number line, here is F0 and another frequency FB is there. Another frequency FB can be here or can be here. If it is increased, then number of beats positive only, and he said delta F2 must be less than F1. That means that must be this one. Then only number of beats will decrease, isn't it? If it is this one, what happens? Number of beats will increase. As it is approaching, number of beats will decrease, means FB should be this one. This one means it is F0 plus delta F1. F0 plus delta F1 should be the frequency of B. So option A. Next. A cylindrical resonance tube open pipe has a fundamental frequency F in air, okay. Fundamental frequency, that I can write F is equal to V by 2L, right? F is equal to V by 2L. And yeah, V by 2L. Some color, yes, V by 2L. Yeah, some people will write N, some people will write F, both are correct only. If half of the length is dipped vertically in water, now the length L dash is equal to L by 2, and dipped in water it will become a closed pipe. So F of frequency is equal to fundamental frequency of the air column will be is equal to V by 4L. This L dash. So I can write V by 4, this is L by 2, that is equal to V by 2L only, both are equal only. So same B option. Yeah, we will go to next question. A wire vibrates at a fundamental frequency of 500 Hertz. Fundamental frequency of 500 Hertz. And a second identical wire produces 5 beats per second. When it tension in the first wire is lightly decreased, the ratio of the tension in the second wire to the tension in the first wire approximately. Second identical wire produces 5 beats per second. With it, when the tension in the first wire is lightly decreased, maybe first both tensions are same, later one lightly decreased. Okay, and he is asking the ratio of the tension in the, so 5 beats it is coming. That means the other one, if it is tension is T1, other one's tension should be lesser, then only frequency will be less. So T2, so frequency less means it is 495. So this is F2, this is F1. You know frequency N is equal to 1 by 2L root T by mu. So you can write it as F1 by F2 is equal to root over T1 by T2. So implies T1 by T2 is equal to F1 by F2 whole square. He is asking that ratio only, I think. F1 is equal to 500 and F2 is equal to 495. And he is asking second wire tension to that of the first wire. Reverse is asking. T2 by T1 is equal to 495. Wait. The ratio of the tension in the second wire to that of the first wire. The second identical wire produces 5 beats per second with it when the tension in the first wire is slightly decreased. Tension in the first wire is decreased. Tension in the first wire is decreased. So first frequency will change. So this is going to become a small changes I want. T1 decreased a little, so frequency will be reversed. This is 495 and this is 500. I have to write. Here also I have to change, right? Yes, this is 500. This is also 500. I'll change like this. After changing the tension, it will become F dash is equal to 495 and this is equal to 500 after changing the tension. Yeah. Then this is only initial tension, this is only final tension. Yes, so T1 by T2 is equal to, this will become 500 by 495 only. So it's almost all 1 point something, very close to that only. 1 point something, very close to. You shouldn't be lazy enough. 1.01 is there, 1.05 is there, 1.02 is there. You need to check very carefully. I did it. Next. An argon pipe with both ends open has the length L is equal to 25 centimeter. An extra bore is created at the position L by 2. The lowest frequency of sound produced is lowest frequency of sound at L by 2. Then this L by 2 only will be under resonance, right? So lowest frequency N is equal to V by, this is open end, open. So when V by 2L, so V by V is 330 or 30, maybe 330 or 300. Let me check this. Yeah, I changed it. That is 340 meters per second he has given. See, if it is a pipe, usually it will come like this, open pipe. But if you open at the middle, what happens, there antinode, an additional antinode will come. If you open here, then additional antinode will be generated here. So system will come like this. So what will be wavelength? L is equal to 25 centimeters. That is equal to antinode to antinode lambda by 2, antinode to antinode lambda by 2, that is lambda equal 25 centimeters. And I can have frequency N is equal to V by lambda. V is equal to 340 meters and this is 25 centimeters by 100. 1 by 4, 25 by 100 will be 1 by 4. Lambda is 1 by 4. 1 by 4 means 4 will be multiplied. 340 into 4. So around 12 after. So 1360 hertz. Yes. Next, two coherent plane waves of identical frequency and intensity interfere at a point where they differ in phase by 60 degrees. Phase difference equal to 60 degrees. What is the resulting intensity? So two coherent plane waves, identical frequency and identical intensity. Then 60 degrees is 4 I naught cos square 5 by 2. Right? This is equal to resultant intensity I. 4 I naught cos square, cos 30 is root 3 by 2, its square is 3 by 4. Why should I waste time? So it must be 3 I naught. Not 31, 3 I. And the standing waves are produced at a string 16 meters long. L is equal to 16 meters long. Here there are 9 nodes between the two fixed ends on the string. And the speed of the wave velocity is equal to 32. Number of nodes are 9 nodes. Number of nodes are 9. What is the frequency of the wave? N is equal to how much? 9 nodes means how many loops? Can you guess? Yeah, you are right. If it is single loop, 2 nodes will be there. If it is 2 loops, 3 will be there. That means number of nodes minus 1 will give you number of loops. So loops is equal to 8 only. So the frequency is equal to P by 2L root T by mu, or V, I can write simply V. Why root T by mu? Simply V I can write. This is V. So number of loops 8 by 2, L is 16 into V is 32. 32 will go. So only 8, 8, 8, 8. There is no 8 here. What did he ask? Frequency. Okay. Which frequency? What is the frequency of the wave? Okay. Standing wave only. Everything okay only. 32. 2 16s are 32 only. Okay. Let me check. Yeah, actually I checked it. He took number of loops 10. The reason is he said between two fixed ends. Suppose this is the fixed end. 9 nodes are there. 9 nodes are there. That means here is one more node. Here is one more node. Total number of nodes 11 nodes. 11 nodes means loops will be 10. Loops will be 10. So by changing that, I'm not cancelling this, and n is equal to P by 2L, 10 by 2 into 30 into 16 into 32. So it will be 10 heads. So he gave between two fixed ends, in between nodes are 9. So like this you can. So this is another way of thinking what he told in the question. I didn't catch that point. So catch very carefully. Next. A wire of length L equal to 50 centimeters and weighing 10 gram is attached to a spring. 10 gram, M is equal to 10 gram is attached to a spring at one end of it and to the fixed wall at the other end. The spring has the spring constant K is spring constant of and is stretched by 1 centimeter. Stretched by x is equal to 1 centimeter. If a wave pulse is produced in the string near the wall, then how much time will it take to reach the spring? Time taken is equal to how much? Okay, so that indirectly giving the tension. K value I noticed as 50 and I can replace here 50. So indirectly he gave the tension T is equal to Kx. That is equal to 50 into x equal to 1 centimeter, 1 by 100. So that is 1 by 2 Newton. With this I can get velocity, not directly, even mu is also needed to calculate. Mu is equal to m by L. M is equal to 10 grams, 10 power minus 3 into L is equal to 50 centimeter, 50 into 10 power minus 2. So it is going to become 0, 0 gets cancelled, 1 by 5 into 10 to the power of minus 1, that is equal to, I'll leave like this. This is mu only. So velocity equal to root T by mu. So root over tension is 1 by 2 and mu is, in the denominator I have to write, mu is 1 by 50. So 1 by 50 will become 50. 50 means 25, means 5 meters per second is velocity. Now time taken to travel is equal to L by V. L equal to 50 centimeter into 10 power minus 2 by 5. That means 10 into 10 power minus 2, that is 0.1 second. Yeah. An amplitude modulated signal consists of a message signal of frequency 1 kilohertz. Message signal frequency of message signal is equal to 1 kilohertz. And peak voltage, I can call it as E. E0 is equal to 5 volt. Modulating carrier frequency 1 megahertz and peak voltage is equal to E carrier is equal to 15 volt, and the correct description for this signal is equal to, this is the equation of a modulated wave. Equation of FM modulated wave is, you see, that is y is equal to EC into 1 plus EM by EC into sine 2 pi FMT into sine of 2 pi FCT, frequency modulated wave definition. So on checking with this and comparing with this, we'll get the option close to B. B, carrier is right. Yes. Next. And a sound wave of frequency nu, frequency is n is nu hertz, initially travels a distance of 1 kilometer. Distance of 1 kilometer in air. then it gets reflected into water reservoir of depth 600 meters. 600 meters. And the frequency of the wave at the bottom of the reservoir is frequency nu2 is equal. Frequency on changing the medium is not going to change. Frequency in every medium will be same only. Wavelength will change, velocity will change. Frequency will be same only. Frequency will be same only. Yes. Frequency nu same in all media. Same in all. Right? Velocity proportional to lambda. V is equal to n lambda. N is constant. Only these two are going to change on changing the medium. Remember. Next. A thin wire of length 99 centimeter is fixed at the both ends as shown in the figure. The wire is kept under a tension and is divided into 3 segments. Okay, as shown in the figure. When the wire is made to vibrate, the segments vibrate respectively with their fundamental frequencies in the ratio 1:2:3. If the lengths of the segments respectively are lengths in the ratio, their frequencies are given, lengths he is asking. Total length is already given as 99. We have frequency f is proportional to 1 by L. So he gave fundamental frequencies ratio f1 is to, f2 is to, f3 which is equal to 1 is to 2 is to 3. That means 1 by L1s, their reverse ratios I have to take. So L1 is to, L2 is to, L3 is equal to 1 is to 1 by 2 is to 1 by 3. LCM is 6. So this will become 6 is to, 6 will go 2 3 times, 3 is to, and 3 will go 2 times 2. So total length will be L is equal to 6x plus 3x plus 2x is equal to 99. So 11x, 11x is equal to 99. So x is equal to 99 by 11 is 9. Implies 6x will become first 2x onwards 18 and 27, 18, 27, 54. So B option. Huh? Oh, be careful. Long one 54. First 54 onwards we have to come. Yes, C option, because B and C are so you should be very careful. Next, small frequency, longer length. Next, an open air pipe of length L is equal to 80 centimeter has second harmonic frequency equal to fundamental frequency of a closed organic pipe. L equal to 80 centimeter has second harmonic frequency. Second harmonic frequency means 2V by 2L is equal to fundamental frequency of closed pipe. Fundamental frequency of closed pipe means 4L. The length of the closed pipe is this is open. Okay. Now VV cut and 2 cut. So LC is equal to L0 by 4, that is 20 centimeter. So next, don't struck. Yeah. Among the following, the equation representing the progressive wave, which one represent progressive wave equation? Progressive wave equation. Which sine function is there, cos function is there. That means that's a stationary wave equation. And sine cos will come. First one is a stationary wave equation. Second one is a progressive one, x and vt. Okay. And the next one, sine c plus cos d, also progressive only. That means b and b1. How can I take b only? So what is he asked? Progressive wave equation. C is also there. So only C option can be represented as a sin omega t or as a sine function or cos function. So probable answer is B option. B option. Option B. Option B. So next, a body is suspended from a string of length L equal to 1 meter. L equal to 1 meter and mass M is equal to 2 gram. The mass of the body to produce fundamental mode of frequency is 100 hertz and frequency of the string is equal to what? Wait. The mass of the body to produce fundamental mode of frequency 100 hertz. Fine. A body is suspended from the ceiling of length. Here n is already 100 hertz is given. Okay, he is asking mass. Tensional mass, not string mass. Okay, if you find the tension, then automatically m will come. So n is equal to 1 by 2l root t by mu. So n is equal to 100, 1 by 2l is 1, root over t is mg by m is m by l. M by L, 2 gram into 10 to the power of minus 3 by L, L is 1 meter, G value 10. So this is 200 into 200 is equal to M, G value 10 by 2 into 10 to the power of minus 3. So 10 power minus 3 will go as like this, and this 0 will go, and this will be 2 2s are 4 2s are 8. M is equal to 8. M equal to 8 kg. Next, a string is fixed at both ends with 5 loops. Okay, the total number of nodes and antinodes respectively. So this is antinode, 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 antinode. How many? Number of loops are 5, antinodes will be 5, but nodes will be 1 extra because edges also you have to count. So number of nodes will be 1 extra, 6 and 5. Next, two waves of frequency f and amplitude are superimposed with each other. The total intensity is directly proportional to two waves, directly proportional to total intensity. I is equal to 4I naught cos square 5 by 2. So 4I naught is equal to Ka square, I can write, into cos square 5 by 2. So this is proportional to 4A square. So this is the answer. Next, on producing the wave of frequency n is equal to 1000 hertz, Hund's tube experiment, the total distance between 6 successive nodes is 85 centimeters. Between 6 successive nodes, L is equal to 85 centimeter for 6 nodes. The speed of sound in the gas is equal to V is equal to how much? So Hund's experiment. In Hund's experiment, 6 nodes means 5 loops. 5 loops means length L is equal to 5 lambda by 2. Implies 85 is equal to 5 lambda by 2. 5 will go 1 time, 7 times. So lambda is equal to 17 2s are 34. Then velocity is equal to n lambda. N is equal to 34 into 10 to the centimeters. Option, okay. L value centimeter. So this is also centimeter. 10 power minus 2 into lambda value. This is n is 1000. So 2 zeros, 340 will come then. 340 meters per second. Am I doing fast? Under standard conditions, the density of a gas is rho is equal to 1400 by 1089. SI unit only. Okay. And the speed of sound of propagation is velocity equal to 330. Then number of degree of freedom of the gas molecule is number of degree of freedom. F is equal to how much? We have velocity V is equal to square root of gamma RT by M. And some manipulations we can make here. That is what is that? RT is equal to M is equal to M by M RT, I can write. We will have PV is equal to M by M RT. So RT by M can be represented with RT by M can be PV by M, that is equal to RT by M. So P into density. Volume by mass is not density. So it is 1 by density. So that is equal to P by rho. So if I replace gamma P by rho, that is equal to V standard formula only. But I recollected this. So velocity 330 equal to square root of gamma, which gas that is? Oh, if you can find out gamma value, then degree of freedom automatically come. Pressure, density is given under standard condition. So that means 1 atmospheric pressure, 10 to the power of 5 pascals. By this one is Density 1400 into 1089. So gamma value will come as, implies gamma is equal to how much will come in this here? Gamma equal to 1.4 will come. 1.4 refers to diatomic gas. Yeah. So degree of freedom will be diatomic gas 5. Two sources A and B producing note of frequency 680. Listener moves from A to B with a constant speed V. If the sound in air is 340, then value of V, so that he hears 10 beats per second. Okay. Two sources A and B are producing notes of frequency 680 Hz. N equal to 680 Hz. And he is moving from A to B such that velocity of a sound is equal to 340 meter per second, and number of beats heard is 10, delta n is equal to 10. Then his velocity must be V equal to question mark. Delta n is equal to 2n Vs by V you can use. Delta n is 10, 2 into 680 by V is 340 into Vs 340. Vs is velocity of source, that only we have to find. How can I write 340? So this will be 2 times. So V is equal to 10 by 4. 10 by 4 is equal to 2.5 meter per second. So that is B. Source of sound is S in the form of a block and is kept on a smooth horizontal surface, is connected to a spring as shown in the figure. If the spring oscillates with an amplitude of 50 centimeter, and to and fro, the maximum frequency heard by the observer is 12.5, more than that of the minimum frequency. Okay, fine. If the mass of the source of sound is 100 gram, the force constant of the spring is equal to, great, mass m is equal to 100 gram and force constant k is equal to how much? If I can have the amplitude, then I can get that one. Yeah. So this speed V is equal to 340 meters per second. You know, maximum frequency by minimum frequency is equal to, maximum by minimum is equal to V plus R omega. Here A omega will be A omega and this is V minus A omega. He gave 12.5% maximum to minimum. So with this you can simplify it, and so that omega will come. So after coming omega, then k is equal to, we can get, not a big task. So n1 n2 minimum, n1 is equal to 12.5 more, that means 112.5. 100 plus 12.5 will be 100 plus 12.5 by 100, that is equal to 112.5. That means 1.125. 1.125 into n2. N2 gets cancelled. This is 340 plus A omega by 340. I can write V maximum, that will be better. V max instead of A omega. V max. Last we can have V max. And that is equal to 340 minus V max. So on solving this, we'll get V max is equal to 20. Yeah. V max is equal to 20 is equal to A omega is equal to A root m by k. That equal to 20 implies k is equal to 160 roughly Newton per meter. Yes. You should be patient enough to solve calculations. An observer moves towards a stationary source. Vs is equal to 0. V0 is equal to V by 5 and speed of the sound. The wavelength and frequency of the waves emitted by the source are lambda and f. The apparent frequency and wavelength heard by the observer is approximately. Apparent frequency n is equal to V plus V0 by V minus Vs into n. Is apparent frequency. So V plus V0 is V by 5 by V. So into n. Here 5 ones are 6 by 5. 6 by 5 n. 6 by 5 means 1.2 1.2 n. Frequency will be 1.2 n. So first option is there, last option is also there. Then wavelength. Apparent frequency is increased, then wavelength should decrease. Here who is moving? First of all, source is at rest, so wavelength will not be modified. Observer will not modify the wavelength. Observer will bag many number of waves or less number of waves. So here who is moving? Observer is moving, so no modification in wavelength, no modification in wavelength. So wavelength will be lambda only. So option will be A only, better. Next, a reflector is moving with 20 meter per second velocity. Vs is equal to 20 meter per second towards a stationary source of sound. Okay, and this is Vs dash or Vr I can write. Then Vs is equal to 0. If source is producing a sound of waves with there is a letter missing, I will find out. Then the wavelength of the reflected wave is, okay, yeah, I found the missing number, that is 160. So we are going to have frequency n is equal to 160, then lambda of incident is equal to V by n. V by n, V is 340 by n is equal to 160. This is incident wavelength. Now reflected wavelength is equal to V minus Vs by V plus Vs into lambda. Yeah, because 2 times you need to consider. This is 340 minus 20 by 340 plus 20 into V by n, that is 340 by 160. This is lambda dash. So lambda dash is equal to some 17 by 11, no, 11 by 17. What's denominator, numerator? Okay, 340 is here, so 17 by 11, 17 by 9. Okay, you can check it up. Okay, this is the formula. Next, for a certain organ pipe, there's 3 successive resonance frequencies. For a certain organ pipe, 3 successive resonances are observed at 425, 595 and 765 respectively. The length of the pipe is okay. So here to here lambda by 2 will come, here to here lambda by 2. No. Actually he is giving the frequencies. Wait. Successive resonances. N1 is equal to 425. Next N2 is equal to 595 and N3 is equal to 765. Open pipe. Open pipe frequencies are in the ratio 1:2, 2:3 and so on, like that only. And the difference will be always V by 2L, isn't it? Difference will be V by 2L and V equal to 340 is given. So what is the difference? 595, 425. 595, 425. This is 0. This is 70. This is 170. 170. This is 340. Huh? So 340, 170 will go 2 times. 2 will go. L equal to 1 meter I have. So B equal to 1 meter. Yes. Next. Transverse wave is represented by the equation. So the measurements are in meters. And the velocity of propagation is equal to omega by k, which is time coefficient by x coefficient. Time coefficient is equal to 30, x coefficient is equal to 40. Answer is 3 by 4, and that is in meters. 3 by 4 means 0.75. Huh? To propagate both longitudinal and transverse waves, material must have bulk modulus, shear modulus, only bulk modulus, Young's modulus, bulk modulus, only shear modulus. Nice question. Huh? So, see, propagation of longitudinal waves. Longitudinal inertia and elasticity must for longitudinal waves. Transverse waves, there is no need of medium first of all, right? So, medium must have both bulk modulus and shear modulus. That means option A. Huh? Option A, yeah. Next one. The equation of a stationary wave y equal to this. The distance between node and the next antinode is lambda by 4. And lambda will come from x quotient. What is x quotient? Pi by 15. Pi by 15 will be k. K equal to 2 pi by lambda. So here pi gets cancelled. Lambda equal to 30 centimeters. Centimeters or meters are units only, he said. Okay, So lambda by 4, node to antinode distance is lambda by 4. Lambda is 30. 30 by 4 is 15. 15 by 2, 7.5. The wave set up in a closed pipe is closed pipe, stationary wave, okay, and longitudinal. Actually, they are sound waves. Sound waves means yes, they are longitudinal stationary waves. So B option. But on strings, transverse stationary waves. Strings transverse stationary, pipes longitudinal stationary. May I write? Strings transverse stationary and pipes longitudinal stationary. Okay, next. When two tuning forks A and B sounded together 4 beats per second are heard, the frequency of the B is, okay, it's missing. Let me find out that number. Yeah, I corrected that. So when two tuning forks A and B sounded together, there is a known tuning fork B. I use number line usually. B tuning fork, whose value is 384, right? 384. And it's producing 4 beats. That means there is a possibility of 380 or 388. Number line in an order you can write. And fork A is filed and sounded with B. Beat frequency increases. A is filed. On filing, this frequency will increase. Filing frequency will filing means rubbing. So this frequency increases and this frequency increases. It can be A or A. We have to decide. If its frequency increases, if it is the answer, the number of beats should come less than 4. If it is the answer, this will come up to here and B is here only. So number of beats will be greater than 4. So tell me, which is the next one? Beat frequency increases. Beat frequency increases means it must be this one. So what is that? 388 before filing. 388 before filing. So option is 388. An engine of a train moving with a speed 10 meters per second towards a platform. Engine of a train moving with Vs is equal to 10 meter per second towards a platform sounds a whistle at frequency n is equal to 400 hertz. The frequency heard by the passenger inside the train is. Frequency heard by the passenger inside the train is. Why inside the train passenger will have Doppler effect? Doppler effect will come with a relative velocity. There is no relative velocity here. So answer will be same. No relative velocity. No relative velocity. Train engine as well as the passenger moves with the same speed. So no Doppler effect. No Doppler's effect. Two identical strings X and Z made of same material having tension Tx and Tz in them. Okay. If their fundamental frequencies are 450 and 300 respectively, then tensions ratio, that's it. So fundamental frequency n is proportional to root t, right? So they have 450 by 300 is equal to root over Tx by Tz. So squaring on both sides. Before that we need to simplify a little. 5 table 6 times, 5 table 9 times. 15 table will go no, simply 3 by 2 is equal to root Tx by Tz. So squaring 9 by 4 is equal to Tx by Tz. So 9 by 4 means 2.25. Huh? Yeah. So these are the questions based on waves. And we'll discuss another chapter in the next session. Keep on practicing. Bye.